Okay, so yeah, so okay, so this is what I'm doing. So I'm trying to do like a quick test to see um one how good I retain information, and two um how long it takes for me to like zone out from learning. So this video will be the kind of like the video I'm gonna use to test this with. This is something I wanted to learn about anyway, so that's gonna be interesting. So it's about wavelengths and stuff, and uh, the sun, really, ultimately the sun. Um, yeah, I just wanted to run this test on this real quick and see how it goes. So this is the video I'm gonna use. Uh, YouTube channel is Fuse School. If you guys can see that.
Why can you see the reflection of some objects? In this video, we use ray diagrams for reflection, refraction, and color absorption. Visible light is part of the electromagnetic spectrum. Light is a transverse wave and travels in straight lines. When light hits an object, it can be reflected, refracted, or absorbed. Reflection is when light bounces off an object. The angle of incidence is equal to the angle of reflection. So if a ray of light hits an object at 45 degrees, it bounces off the object also at 45 degrees. Or hits at 30 degrees, and it would reflect also at 30 degrees. A rough surface, like wood or clothing, scatters the light so that it reflects in all directions. Smooth surfaces, like glass or polished metal, reflect the light in a regular way, so a reflection can be seen. When drawing ray diagrams, the angle of incidence is always equal to the angle of reflection. The angle of incidence is the angle between the normal and the incoming incident ray. In this question, can you work out the size of angles I, Q, and R? Pause the video and work them out.
The angle of I. Uh,
Did you get the angle of incidence?
I think you had to do math to do this or something.
This is 34 degrees. And the angle of reflection is also 34 degrees. And angle Q is 56 degrees.
Okay, so
You label the different parts of this reflection ray diagram. Pause the video and give it a go.
wait, I'm trying to see the question they asked here.
Parts of this reflection ray diagram. Can you label the different parts of this reflection ray diagram?
Label. Okay, so I'm saying Y is the inflection and N is the reflection. Y and R. Wait, no. Y is the inflection. R is the angle of inflection. M is the angle of reflection. N is the reflection itself. Okay. Y is the 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 ray. Okay, I'm already losing it. Reflection. So Y is inflection. R is the angle of the inflection. M is the angle of reflection. And N is just the beam of light reflection. H, I guess if H was a ray, I have to see.
Give it a go. Did you get them correct?
Okay, so I'm getting words confused and whatnot. So incident ray. Okay, I had the logic right, but the words. So I'm gonna note that. So the logic was right. Incident ray, the angle of incident is R. M is the angle of reflection. N is the reflected ray. H is normal. Yeah, it's just normal. Okay.
So what
So,
happens during refraction? Sound
okay.
waves
So I'm gonna note that actually right now. Sorry guys. Sorry. Gotta do this. We're gonna create it in the iNotes. Okay. So, learning style. We're just gonna know the learning style. 7/1/26. Boom. So logic. That's good. Wording on unfamiliar words. It's like use word. Yeah, so I literally forgot how to pronounce that word in like 40, 50, or like a minute or two. So, yeah, that's cool to know.
waves change speed when they pass across the ray diagram. Pause the video and give it a go. So what happens during refraction?
Fraction.
Sound waves and light waves change speed when they pass across the boundary between two substances with different densities. What happens during refraction? Sound waves and light waves.
Okay, so I got another note. So I got this dehumidifier going on in the background, and it is like zoning me out. It is zoning me out. So headphones may be a good choice of what to use when trying to learn. So external sound is taking away my focus. Headphones may be needed. Okay, back to the video.
Change speed when they pass across the boundary between two substances with different densities, such as air and light. Correct. Pause the video and give it a go. So what happens during refraction? Sound waves and light waves change speed when they pass across the boundary between two substances with different densities, such as air and glass.
Okay.
This causes them to change direction, which is called refraction.
Refraction.
If a light wave passes from a medium in which it travels faster to a medium in which it travels slowly, then the light wave will bend towards the normal. Whereas, if it goes from a slower medium to a faster medium, the light wave refracts away from the normal. Just like with reflection, refraction also has an angle of incidence and then has an angle of refraction. In refraction, the two angles do not equal one another because they are traveling through a different medium.
Yeah.
The greater the change in speed, the greater the angle of refraction. There is one special case you need to know. Refraction doesn't happen if the waves cross the boundary at exactly 90 degrees. If this happens, they carry straight on. Because of refraction, water looks shallower than it really is. And a straw in a glass of water looks like it bends on the surface. The light ray refracts as it leaves the water, making the straw appear bent. So there we've seen.
Okay, that was something I did always notice in water that I was always curious to know why about. It's like water bending the imagery of things. Yeah, from how they look, but not actually.
And refraction and the associated ray diagram
mirror reflection. So incident, normal reflection, incident ray, refraction.
Both have an angle of incidence, and then there is an angle of reflection or refraction.
Okay. Okay. I'm gonna try not to leave this video until like I give a okay wording that I understand it, at least on a basic level. I'm not a physician, but let me give it a go. So the words I'm getting is inflection, which I believe that's not the right word. So it's incidence. So I'm mixing incident with reflection and creating inflection, which is not even a word. So the word is incidence, the angle of incidence, like where the ray starts or where it's coming, where it's coming from originally. The angle of reflection is the angle the ray has reflected to after hitting the surface of the incidence. Okay, that's for reflection. And for refraction, same with the incident ray and an angle of refraction. Okay, so incident and reflection. Oh my God. Incidents. Oh, that's why I'm getting confused. So the words are different. Incident ray and angle of incidence and angle of reflection and reflected ray. Okay. Yeah. Okay. Okay. Gotcha. Okay, so I think I got a okay, clear understanding of it, but there was parts in the video where I was being thrown off significantly. Coming down to the refraction part specifically. So, how they describe this with the slow, like the ray going slow, then going fast determines how big the angle will be. That part was throwing me. So that had a little bit more complexity to it.
From a slower medium to a faster medium, the light wave refracts away from the ball. Just like with reflection, refraction also has an angle of incidence and then has an angle of refraction. In refraction, the two angles do not equal one another because they are traveling through different medium.
Different mediums.
The greater the change in speed, the greater the angle of refraction.
Okay, greater the change in speed.
There is one special case you need to know. Refraction doesn't happen if the waves cross the boundary at exactly 90 degrees.
It doesn't happen. Okay, I kind of get that. It just goes straight through.
This happens, they carry straight on.
Oh, that makes sense. That makes sense.
Because of refraction, water looks shallower than it really is. And a straw in a glass of water looks like it bends at the surface. The light ray refracts as it leaves the water, making the straw.
I'm trying to visualize this in a different way, or like myself seeing it. Like this part is, it's a little challenging actually.
And a straw in a glass of water, so it looks like it bends at the surface.
Looks like it's bent.
The light ray refracts as it.
Oh, because it's okay. The glass, yeah. Okay, yeah, so this is really what's doing it. This part right here.
leaves the water, making the straw
Get that out the way.
or appear bent.
Mm.
So there we've seen reflection and refraction, and the associated radii.
Hold on, that's actually cool. Like every time I look at glass, I'm gonna look at it differently now. That's cool. The light.
Appear bent. So there we've seen reflection and refraction.
Yeah. This is a cool video. Alright, so this is the end of the screen. I guess I will note my learning style. I wasn't originally going to do this. Like this popped up in my head as I was starting, but it's a cool thing to know. Logic is good. Logic is good. Wording on unfamiliar words needs work. So yeah, I was switching the words like with other words, mashing them together. External sound is take away my focus. So this thing in the background, you guys can't see it, but I can feel it like putting me in a trance almost, to where I'm not focusing as much as I should be on it. Or maybe I doubt I'm bored. I doubt it's unstimulating, because I mean, it was interesting to know. Maybe it could have been, though. We'll find out with deeper studies and whatnot. But when I visualized it myself, it did seem to be a little bit more cooler, like visualizing myself seeing it rather than just watching a video explaining it. So yeah, that's all for this video. How would I rate my memory retention from watching this video? I would give this a like a 8 or 9. I could literally see the video in my head right now. So yeah, I liked this video a lot. I'm gonna like it actually. Boom. Yeah, that's all for today's screen. If you guys want to see more videos like this, hopefully when I actually learn the stuff, I could make videos on it, giving my personal view or just interesting facts, or just different perspectives on it, or my perspective on it entirely. Yeah, but I can't really do that right now, and I'm just learning new ways of learning, and testing, experimenting. If you guys haven't seen my previous live stream, that's where I'm doing a 7-day experiment to see how my sleep score or my sleep quality changes, from going to bed at the same time every day from 9:30 p.m. to 5 a.m. And that's only one part of an ongoing series where I test different variables to see which variable um, has the biggest impact towards sleep, and not only test but note the data. So I give you guys a quick glimpse of that. New notes. Is it the new notes? It's not the new notes. Daily test. It's not the. It's this one right here. So I give you guys a glimpse of that. So I'm noting everything from my deep sleep, REM sleep, sleep scores, sleep latency, night awakenings, bathroom breaks stuff, notes like I drank a sip of water, that may have been a reason I went to the bathroom at nighttime, and just like understanding the data of why people have bad sleep versus good sleep, and understanding what variables most importantly contribute to either or. So that is all for today's stream, and if you want to stick around and see how those series go, the different tests, the different experiments, feel free to stick around, and yeah, you guys take care.